Hello, geometers. This is Ms. Backfish, and I am here to talk to you about medians of triangles and centroids. So let's just jump right into that. I have a triangle here. That's the basic requirement. And then I wanted to talk about what a median is. A median is a segment which starts at one of the vertices. Remember that the points are our vertices. So it could start at any of these, at A or B or C. It starts at one of the vertices, and I say starts, but it has an end at one of the vertices. And the other end, not the straightest segment I've ever drawn, but the other end is the midpoint of the opposite side. Okay, so these two markings are me telling you that this point, let's call it M, is the midpoint of segment BC. It divides segment BC into two congruent smaller segments. So this segment that has a vertex on one end and a midpoint on the opposite end, that is a median. And in every triangle, I could draw three medians. I can go from any vertex, like B, to the midpoint of the side across from that. I could go from here to here, and if this is a midpoint, that's a median. So I can draw the three medians. Now, one of the special things about the medians is that they actually meet all together in one point. In other words, if I were to draw all three medians, so let me go ahead and do that. Okay, so I just drew another median here, and it's supposed to be blue. I'm having some color differentiation issues. I don't have the color options I normally do. Anyway, these three different medians will always meet at a single point. And that may seem like, well, of course they would. Well, not really. If you have three different lines, it's much more common for them to meet at 1, 2, 3 different points. So for you to have three different segments and they all happen to meet at the exact same spot, that's kind of special. And that's something that happens with a lot of different types of segments or several different types of segments in triangles. And where they meet, we call a triangle center. So this is one type of triangle center. There's not just one center of a triangle we can talk about. There are actually four. They are the orthocenter, the incenter, the circumcenter, and what we're talking about right here, which is the centroid. The point where the three medians meet is called the centroid. Okay, it can be called a point of concurrency. That's a way of saying when lines are concurrent, that means that they all meet at the same place. A bunch of things happening at the same place in the same time is concurrent. So when three lines or more meet at just one point, we call that a point of concurrency. That's a general term. The specific term for the point of concurrency of the medians is the centroid. Okay, so now that has the centroid and the medians have a couple of special relationships that we need to, well, it's really one special relationship, but it has a couple of implications we need to get into. So let's go ahead and look at another one. So here we have another triangle, and I went ahead and drew a median, and I stopped here just because I want to remind you, this is how I know this is a median. On one side, I see these two marks, and that tells me this is a midpoint. On the other end, it touches a vertex. That's what a median is. It's a segment that goes between a midpoint of one side and the opposite vertex. Okay, so there's a median. Let's go ahead and draw another one. I'm going to make the midpoint of this side, and then here's a vertex. Let me see if I can connect those with a nice straight segment. Pretty good. Okay, so here they meet, which means that's the centroid. Let me give this some letters. How about Q, R, S? I'm labeling my points. M, N, and let's call this C for centroid. The centroid, here's the special part. The centroid is located 2/3 of the distance from the vertex to the midpoint. Okay, so now I've written that. Let's say it again. The centroid is located, we can find the centroid, 2/3 of the distance from the vertex to the midpoint on each median. So 2/3 of the way, if I start at the vertex, I go 2/3 of the whole length and I get to the centroid. So as I'm going from the vertex to the midpoint, and that's what every median has, a vertex on one end and a midpoint on the other, I go 2/3 of the distance and I hit the centroid. That means there's 1/3 of the distance left. So let's just look at basically how we can have a segment partitioned that way. thirds. That means 3 pieces. So let's divide this segment into 3 pieces. Okay. What if this is the vertex? All right. 2/3 of the distance from the vertex means I go 1 piece, 2 pieces. This is where the centroid would be. The centroid would be 2/3 of the distance, 2 parts over here, and only 1/3 left before I get to the midpoint of the opposite side. Okay, so let's look at some distances. What if the whole thing had a length of 30 units? Well, if I take 30 units and I divide it into 3 parts, that tells me I would have 10 here, and 10 here, and 10 here. So the part between the vertex and the centroid is 2 parts out of 30, which is 10 plus 10 is 20. 20 is 2/3 of 30. The part between the centroid and the midpoint is 1/3. 1/3 of 30 is 10. Okay, let's look at another one like that. Let's say it doesn't have to be from a left to right thing, so let's go like this. Let's say this is my vertex and this is the midpoint. Okay, and the median is divided into 3 pieces. Equal pieces, just like taking a candy bar and cutting it into 3 pieces to share with 2 other people. Okay, the centroid is located 2/3, these are thirds, so 1/3, 2/3 from the vertex to the midpoint of the opposite side. That's where my centroid is. So let's suppose that this is segment LK or KL, either way. And what if I'm told that the entire length of KL is 18? Let's say centimeters. Well, if I want to know how much is here and how much is here, let's call this point J. If I want to know what the length of JL is and what the length of JK is, I have to take this number, divide it into 3 pieces, just like cutting that candy bar into 3 pieces. 18 divided by 3 is 6, which means I have 6, 6, 6. Okay, so this is 2 of the 3 pieces. 6 plus 6 is 12. So the length of JL would be 12. And the length of JK is just 1 of those pieces, so it's 6. The longer side, because of the way this is stated, remember, it's located 2/3 of the distance from the vertex. The longer part or the larger part is always the part on the vertex side. That's the 2 pieces. The 1 piece is always the one on the midpoint side. So let's go back and look at that in context. All right, what if I was told that segment QC had a length of 14 units, and I'm not going to worry about the units right now. All right, well, here's the vertex, here is the midpoint on QN, which is the median. So on the vertex side is where it's 2 pieces. On the midpoint side is where it's 1 piece. So it's kind of like I'm dividing up my segment into 3 parts like that. 2 parts over here, 1 part over here. If the 2 parts together are 14, 14 divided by 2 tells me each of those parts is 7, which means this part would also be 7. So that means that now I could tell, if I'm asked, I could tell them the length of CN is 7, or I could tell that the length of QN is 7 plus 7 plus 7, which is 21. All right, let's do another one like that with MR. What if I was told that the length of MR, let me see if I can find another good color here. Not really, but we'll see. What if I was told that the length of MC, let's go with that, MC is 8. 8 units, whatever my units are. MC is 8. Okay, so I'm going to label it, that's 8. Now, on MR, this is the vertex. The vertex is one of the corners of the triangle. So this is the vertex, this is the midpoint. The vertex is the side that's bigger. So 2 parts of 3 are here, only 1 part out of 3 is here. So that means if I divide this whole segment into 3 pieces, each piece, if this is 1 part out of 3, each piece has a size or a length of 8. So this would be 8, and this would be 8. So that tells me if MC is 8, that CR must have a length of 16, 2 times 8, and that the whole segment MR must have a length of 3 times 8, which is 24. Another pattern to notice here, if we are comparing a side that has 2 pieces, or 2/3, because thirds are my pieces, each piece, when I'm cutting into 3 pieces, each one is a third. So 2/3 on one side, 1/3 on the other side. 2/3 is twice as big as 1/3. If I have a candy bar and I cut it into 3 pieces, 2 pieces out of that, 2/3, that's twice as many pieces as the person who gets 1/3. If I gave one person 2/3 and the other person 1/3. So, whoa, I'm upside down, sorry. And now I'm upside down. There we go. So the side that is bigger, the side with the vertex, is always twice as big as the other side. 2/3 is twice as big as 1/3. So this side is 16. That's twice as big as 8. And on QN, this side is 14. That's twice as big as 7. So that's the other way you could think of it. So several different ways to look at this. The longer part between the vertex and the centroid is 2/3 of the whole thing. The shorter part between the midpoint and the centroid is 1/3 of the whole thing. And then the longer part is twice as big as the shorter part. Let's do a practice one or two. Okay, here we have triangle ACE, and I have midpoints. I'm going to go ahead and mark them as midpoints. There's a couple of ways this could be done. You could see the markings like we did over here that told me that they were midpoints. You could be told AD, BE, and CF are medians. If you are told they're medians, that tells you that these points are midpoints. Or you could be told that G is a centroid. And knowing that G is the centroid tells you that the medians are those segments that meet there. Okay, so different ways we could be told. Let's just go ahead and assume that we're told AD, BE, and CF are medians instead of seeing markings. Okay, so that tells me that B, D, and F are all midpoints. Now let's suppose that I am given this information. Let's suppose that I am told BC is 12, BG is 9, AG is 10, F, no, yeah, let's go with F. FC, let's write it over here. FC is, I'm going to say, no, I don't want to do that. Let me think. How about 12? FC is 12. Yeah, let's start there for right now. Okay, so first thing I want you to do is I want you to find the length GE and the length BE. So pause your video now and find those. Okay, so GE, I'm going to go ahead and tell you, so if you haven't paused yet, here's your chance. BG, that's from the midpoint to the centroid, so that's the smaller part of this whole median. So that's 1 piece out of 3. If 1 piece out of 3 is 9, that means 2 pieces are on the other side, so that's 9 plus 9, that's 18. And then I know that all 3 pieces together, 9 plus 9 plus 9, is 27. Okay? The next thing I want you to find is I want you to find the length DG, and I want you to find the length AD. And again, pause your video here and see if you can find those two. Now I'm going to go ahead and do it for you. So if you haven't had your chance to pause it, do it now. Gone. Okay, so here's the midpoint on AD, and here's the vertex. So the side with the vertex, remember, is the bigger side. So this is 2 out of 3 pieces. If 2 out of 3 pieces are 10, then if I split that into 2 pieces, that would be 5 and 5, which means over here, that's 5. So the length of DG is 5, and the length of AD, 1, 2, 3 times 5 is 15, or you could also think of it as 10 plus 5. All right, let's do another. This time I want to remember what you were given over here, and I want you to find FG, the length of FG, and also the length of GC. Pause your video. Okay, now I'm going to do it. So if you haven't paused, last chance. All right, so if FC is 12, that's the entire length. So that means that whole length is being divided into 3 pieces. 1 piece is over here with the midpoint. 2 pieces are over here with the vertex. If I divide 12 by 3, each piece has a length of 4. So 1 piece of 4 over here and 2 pieces of 4 over here. So FG is 4, GC is 8. Okay, last thing I want to ask you is, what is the length of AC? Pause your video if you need to. Remember, the whole idea is that if I'm told these are medians, this point, and this point are midpoints. So that means that B is the midpoint of AC. So if this side is 12, this side is 12. Okay, don't forget that you have that fact that these are all midpoints, because sometimes you might be given, I could have given you 12 and then maybe told you how long AE was and given you one of these parts and asked you to find maybe the whole perimeter. Okay, so if this is 12, this is 12, so the length of AC is 24. All right, I hope this has helped you work with medians and centroids, and I'll see you next time. Bye-bye.